It must be, yeah, it's recording now.
Perfect. So welcome everybody to this new event. This is the Cloud Native Asturias April 2021 event. Thank you everybody for coming along. Today we have a very good deck. We have two very interesting speakers with two very interesting topics. I will introduce you this very, very soon. But of course, Angel, how are you doing, man?
Good. Typical. I'm really good, thanks. Welcome everybody, and yeah, hope you enjoy the session that we have with these two great speakers. So yeah, thanks for coming along.
Cool. So I will invest just a few minutes on my side, okay, just to introduce the talk, the session today, and I will let the stage to the speakers, which are the ones that are really important here. Of course, this is our motto. Cloud Native Asturias is an official community group from the Cloud Native Foundation, and because of that, we have a code of conduct. Of course, nothing very strange. Just be nice with the people. In case you have any comment or whatever, be respectful, and that's all. We introduced these new slides lately in the last monthly events. So we want to put Asturias in the map. And since we have now today one of the speakers coming from Zurich, I know that he already knows how to reach Asturias. I'm pretty sure he knows. But just for the people that wanted to know, okay, how can I reach from Zurich? This is the way. By road is take it like a ride. If you want to go by plane, you don't have direct flight. Here, Google Maps is lying. You have to pass by Madrid, and then you can jump to Asturias. And in this case, we went very far. In this occasion, we have a speaker from Costa Rica, from Heredia. So in this case, yeah, it's quite a huge ride for sure, but not impossible, Not impossible. And yes, of course, you can follow the conversation in social networks, in Twitter. We will post several photos, and you can follow the conversation here if you want. This is the agenda, okay? Service levels and error budgets. And after that, from data to knowledge, observability in the world of the ephemeral and the distributed. We will start with Ramón for this initial talk, service levels. Ramón Medrano is a site reliability engineer at Google in Zurich, as I mentioned. He has a very long experience in this matter and other matters. He was also working at CERN, developing and designing distributed systems for all the physics that they have over there, which is really, really interesting. And let me introduce as well Leonardo Murillo from the other side of the wall. He's founder of the Cloud Native Architects, speaker in the Cloud Native Foundation. You can find him in LinkedIn as well. He's very active, and he's very proud. And I can tell you, it's a very nice chapter. Another cloud community chapter that is about Costa Rica. Is from Costa Rica. I can recommend you to go over there and take a look. So, as usual, we will open the Q&A session. You can see in the right side of your screen, of your dashboard, of your browser, that you can access to the Q&A. Feel free to put your questions over there. We will gather all together, and we will ask to the speakers once the talk is finished. Just the last slide before to start. Call for papers. If you are interested to have a talk like this, just drop an email or just fill up this web form that you can find here, and we will consider for your talk. Actually, many people that we have in these events are coming from this call for papers. So thank you very much for collaborating. So that's it from my side. And now, as I mentioned, I let the stage to Ramón. Ramón, it's all yours.
Thanks for the gently introduction. Let me try to find my window here because I have like a 600 million. Okay, I'm I did it right. 600 million Chrome tabs. So I am Ramón, as Marco said, and I work at Google. I'm a staff site reliability engineer, and we're going to be working through some slides today speaking about SLOs, right? So if you're familiar with DevOps, basically SRE is an implementation of DevOps. So all the principles, everything is the same. What we do is we use SLOs as at the center of what we do to prioritize work, relate with developers, relate with product, etc. Right? So this is what we're going to be talking today. If you just some advertisement here, if you want to know more about the differences or the implications or how to implement SRE in your team, or if you are a DevOps engineer and you want to see how it looks like, there's this book that you can actually read for free in this URL, and it explains different aspects of what we do, right? So first of all, we're going to cover these 4 things, and we're going to be speaking about services. For the context of this talk, a service is just a binary running in some place. Could be Kubernetes, could be like your workstation, whatever, that has an endpoint that you can send RPCs. It could be HTTP endpoint too, right? But basically, it's a transactional service. You call, gives you an answer, and that's it, right? Simple stuff. But the building block of the internet these days. So, what is an SLI? Is the first thing that we need to define here. So, an SLI is just an indicator. It's a service level indicator. So, it's just a way to indicate how good something is. That's it. Like it's basically an attribute, right, or a set of attributes of your service. Could be many things, right? Could be, for example, quantities of like how much performant is your service instead of throughput, latency, right? Stuff like that. Could be about availability. That's one that is important too, or interesting. That is how often your service is, or what is the proportion of time your service is available and reachable for your customers. You want to maximize that, right? And another one that is usually not being considered in SLIs, but that is as well very important, is correctness, right? Whether the work that you're doing is correct. There are services that correctness is binary, is either correct or not correct. For example, my team runs authentication services. Authentication can only be correct, right? You need to authenticate the right user to the right account with the right credential. If anything of that breaks, you are going to have a hard time, because if you authenticate a user with their credentials but to the wrong account, you're screwed, right? And if you authenticate users with random passwords, then you are as well screwed, right? There are other services that correctness is not binary, so it's progressive. Like, for example, if you look at the search engine, you could have pages that you are serving that they are not all correct. For example, you don't have all the like top tier results, or you don't have all the features in the page, right? But you are able to serve something to the user, right? So you could have a gamut of correctness there. But that's an attribute of your service too that you need to take into account. So how you choose indicators, right? That's very easy, right? So you always choose the same. No, I would say this is the hardest point that you have to make for defining how you are going to define your SLO for your service, because the indicators you choose are going to reflect in what you do with your service later on, right? If you choose to have only availability metrics in your SLI, right, you're going to optimize your service for being quite available, but you are not going to be looking at correctness, for example. So depending on the service that you are looking, you will need to choose some of them. It's not going to be just one, right? You might have to choose 2, 3, right? Just don't choose 15, because then it's going to be just unmanageable, right? But one thing that is very nice to do when you have a service that you do not have an SLI is just look at the logs. Look at the logs and see what you find in there. Like gather some metrics, use some like BigQuery kind of like unstructured data engine that you can consult and see what are the metrics, how it looks like, right? And then from there, start from that. It's important that if you have a service that is not instrumented, do that, instrument it, so you can observe what you're having, like export metrics to Prometheus, to whatever is what you're using, right? That's usually great, because then you can start seeing what is happening in there. Otherwise, you are flying blind. Right? So let's define one indicator as an example to see how complex it could get, right? What we want at the end of the day is a metric that is a number that we can quantify, right? But there is properties that we need to make sure that we cover. So let's start with latency. So we want to make sure how fast our service is serving to our users, right? but we need to specify more because latency can be more. So let's just specify the latency of the GET requests in our HTTP endpoint, for example, right? That would be nice if you have a front-end service. That's very typical, right? You just serve request to user. Let's see how fast, right? We want to measure it on the client. That's a nice question too, because if you measure it on the client, you are going to have the picture end-to-end of how the user is seeing your service. Like you are going to incorporate in your latency metrics, for example, ISPs that they are out of your control. But that's nice because you can see actually what the user is seeing, what is the final experience of the user, right? You could choose to measure it on the server because it's easier, right? But then you need to account that when the byte goes out into the pipe to the user, you don't know what is happening after that, right? So you need to make a call there. Instrumenting in the client is harder and more expensive, but gives you more information. And then what's going to be the universe of measurement? For example, if we have a server that is a service that is replicated in like a replica set in Kubernetes or whatever, right? We could choose to say like in whatever, right? Or we could choose to have granularity. We could say like I want indicators for the users in Europe, for the users in the US, for example, separately, or I want indicators for people that is using my Canary replica or my production service. For example, you can have the granularity you want to in there, right? Or you can have everything. You can just label it and then do slice and dice, right? So the result is that your indicator is the HTTP GET latency measured on the client every 10 seconds by a black box prober across all front-end servers. Well, that got more complicated than latency, right? And more specific, right? So we call it like client-side latency, just for a shorthand, right? So basically, what's happening here is that we are just having a prober that is telling us how things are performing, right? And then you instrument the service, you start collecting your metrics, and you see stuff, right? And you see like my server is just wonderful. I'm serving like performance, like 20 milliseconds flat. There is some bumps there, but who cares, right? It's just perfect, right? Then you start looking into more detail, right? So let's say like this is an aggregation of every 5 minutes, right? So you get your data points in your Prometheus or whatever it is, right? And then you aggregate and get an aggregate point for every 5 minutes you get one, right? So you can get, for example, 90th percentile of the average, right? So let's just increase the resolution, right? And you see like, oh, this is the same time series, right? And this looks quite crappier than before, right? It's like, well, that's not great. It's not bad. Like if you look at the dynamic range, it's from 20 to 21, so it's within a millisecond, right? So why not? Like it's okay, right? Let's just give more resolution. 1 second. Oh, this is telling us stuff, right? Because when you have that service level indicator, you know how your service is being used by users, right? You know something that is very common in internet services, that is your latency is all fine, except at some like time that is round, like o'clock, quarter past, a half hour, or quarter to the hour, or every 5 minutes. There is always people that is doing synchronous, like for example, you have robots or you have applications that are synchronizing every 5 minutes or whatever. So you always have or tend to have this class of pattern, right? And the thing is that the service, for example, depending what is your objective, right, can be burning quite a lot of your error budget, that we'll see what it is now, in those small intervals, right? So you need to understand very well how your users are using your service, right? So you can set an appropriate SLO, right? So now that we understand this, right, well, a recommendation before moving to the SLOs, use histograms, right? The only way to understand well your metrics is with an histogram, right? This is a heat map, right? But basically what it shows is the different percentiles of latency. There is even more fancier ways to do it with the heat maps and so on. But instead of having 1 point of the average, right, it's nice to see the distribution because you can see the tail of what's happening. So for example, here, the median is always gray, right, and so on, but something after 10:30, something is happening there, right? Because your tail is not great. And it's just spiky and so on. So it's something that is worth investigating what's happening. Maybe some backend is broken or whatever. We don't know, right? So then the indicator just becomes more complex because we are not using a metric like a scalar metric, but we are using a distribution or a property of a distribution. In this case, we are going to be something that is very relevant and very commonly used is a percentile, right? So we want to say like my indicator is going to be the 90th percentile of the latency measured in the client, right? Because that reflects more your distribution, right? Typically, for example, at Google, we will use many of them. Like we would use either the whole distribution, or we will say like, I want to have an SLO for the median, for the 80th percentile, the 90th percentile, and for now it's like 99.99th percentile, right? And with different targets of latency. So you could as well detect problems with your tail latency, right? So now that we know how to describe our service and how to have indicators of how it's performing, right? We need to see that the SLI is only telling you what is happening, but it's not telling you any indication of goodness. This is the fact. This is how the system is performing. And even if you have something like this, is this good or bad? We really don't know, right? So this is where the SLOs come into, right? So what you need to say is like, what is my objective where I consider my system degraded, right? Could be that it's just so high that what you're seeing there is a system overperforming and just noise that you really don't care, right? So an SLO basically is the question of like how fast, reliable, available, correct we want our system to be to consider it that is performing in nominal terms, right? So if you are choosing 100% of any of those metrics, you're doing it wrong, because basically that's impossible. That's impossible because if it will be just so much expensive to have nothing failing or all the requests succeeding on the user side that is just not possible. It's just all complicated, and one request is going to fail. So 100% is not possible, right? You can have many nines. You can have 99 point so many, but not 100, right? Something is going to fail at least once, right? For example, a service that I have in my team, it has 6 nines of SLO. That is going to be 99.9999%, right? And we have many others that are going to be like availability of like 3 or 2 nines, depending on the importance of the service, right? The more down in the stack it is, the more nines you will have, right? One key takeaway for this is that every 9 you add is going to divide by 10 the errors that you are going to be allowed to serve, right, to your users without entering integrated mode, but it's going to multiply by 10 the cost of the services, right? Because it's going to just, we are going to need to have more complexity to be so reliable, right? So generally, the recommendation is to set something achievable. So, like, for example, if you're going to use the percentile 95 of latency, say like, okay, we're going to use the percentile 95% of latency, 99.9 of the time is going to be less than 250, right? And that sentence says a lot of things, right? The second bullet here, the first white bullet, says a lot of things because it's concise, and it's going to be encoding latency and availability at the same time in the same SLO. Because if you say like the latency should be in the percentile 95 less than 250 milliseconds, you have a Boolean for each evaluation of the SLI. You have a Boolean. It's like, is under 200 milliseconds or not, right? And then what you need to collect is all the metrics in a month, and it's going to tell you, yes, yes, yes. Now here it was up. No, 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 no. And 99.9% of the time, that should be true, right? And the nice thing is like is encoding availability, because if you are not available, your latency is going to be infinite. No one is going to see your service, right? So it's encoding like you are going to have 3 nines of availability plus your need to be fast. So your service needs to be up and needs to be serving fast enough, right? So what we said, the SLI should be under the target or between some bounds, right? And then one recommendation there is to publish the SLOs. Like SLOs is the best exercise you can do is to be transparent about them, because you are setting an expectation for the customers. It's like, okay, so I'm going to use this storage system that is going to have my percentile 95 of latency is the objective is less than 250. So I can design my system in a way that I can use this system, right? And I could do some assumptions, and I could add my own layer of redundancy or whatever, right? But that sets like a contract with them. If you have customers that they are paying and so on, you actually will have a contract that is called the SLA. right? So it's the agreement of like what happens when you are out of the SLO. Like when you violate your SLO, are we going to give you like economic compensation? Are we going to give you credits? Are we going to redesign the system? Whatever that would be. Right? It's nice to be slightly better than the SLO, but not a lot. Right. So if you have an SLO of saying like I'm gonna fulfill my requests in less than 250 milliseconds for percentile foo, right? And then you are always in 20 milliseconds, right? What you are gonna create is a false expectations in customers, right? And then when you violate your SLO, when you are not violating your SLO, but you are slightly slower, people are going to assume that the SLO is not there. And all the systems that are built on top of your system or your service, right, are going to be built on the wrong assumptions, right? So you are going to be forced to have an SLO that is much tighter and therefore much expensive than is needed, right? If you are really good, for example, we have a system that is called Chavi that is like a zookeeper or etcd, right? And it's really good. This is a system that is simple, right? It has been running for years and it's just really rock solid, right? And they have an SLO, but they consistently beat the SLO, right? Because it's just there's no risk in the service just because it's just stable. There's no changes going on, right? So what they do is they schedule downtimes, right? Because when an actual outage happens, right? Customers need to be prepared to tolerate those classes of outages, right? Just don't break it in your peak of traffic and so on. So just don't be like a pain for the company, but try to see how your customers are using your service, right? So when do you have to make it better, right? And this is when the error budgets come. The error budgets, they are a concept that is fundamental for an SRE, and it's just using the SLO for your benefit. Right. So if you look at the SLO of 3 nines, you are going to have the availability or the possibility to be 0.1% of the time unavailable, right? So let's use that, right? So if you have a service of 3 nines, it's just roll it out fast. You don't care if you burn some SLO in your rollouts. Just go do it, right? It's cheap. Just you put some rollout automation that goes. Yes, it's going to burn some SLO from time to time. That's okay. If on the other hand you have a service that is having an SLO of 5 nines, right? Oh, you need to be more careful because you have less error budget. So then you have to invest because you have to do a rollout, for example, that is much more strict and controls much better all the possible errors and doesn't burn SLO because you don't have it, right? So lower SLO, more error budget, more freedom to do projects, right? Higher SLO, less error budget. You need to focus in reliability for that service. Right? And that's a very nice conversation because as well, when you get into the product people, they're going to tell you, I want 16 nines because my product is so important. And you say, okay, that's all possible, right? You are going to need to give me 150 people to implement that. And they're going to say, well, that's kind of expensive. Let's just go with 3, right? And then you say, well, I'm going to be able to support that with 2 people, right? So this triangle of like developers, product, and SRE speaking about the SLOs is very nice because you can set priorities, you can drive reliability as you need, and you can set the cost of running a service in one simple conversation, right? And that's what I was meaning, right? So there is a balance between velocity and reliability. The higher the SLO, the less error budget. Therefore, you need to go slower because if you have a small glitch, you are going to burn potentially all your budget. If you have a service that has a lower SLO, just go fast. Like you have enough headroom to burn, right? Just don't be reckless, but go faster. So there is sophisticated error budgets that we can have. For example, there are times that you can have a slow burn of SLO that we call. That's something that is a bit advanced. That is just forecasting how much time do you have until your error budget runs out. Like the systems, usually they are burning slowly some SLO because there is always some backend that is slow, there is some rollout happening and so on. So it doesn't need to consume SLO exclusively on outage. There is always some background burning there. So you can forecast how much time do you have left in your window to calculate the SLO, right? And the nice thing is that you can tell, like, you are going too fast. Right, you can alert people and say you are burning too fast, so you still have headroom, but the trajectory is that you are not going to be ending your quarter or your month or whatever is your window, right, with enough SLO remaining to be compliant with what you have promised to your users, right? And then finally, in my last 3 minutes, this is tight. So what we do, many things, what you can do, depends on the service, right? From standardized infrastructure to making things more effective to production freezes, right? We have called the developers and saying like, you have consumed your SLO. You can't release anymore this month because you are out of error budget, right? That's something that you can certainly do, right? And then automatically those developer teams are going to say like, holy guacamole, we need to invest in reliability because otherwise we can just get features out the door, right? And this is a slide that basically the summary of this whole text is that SRE owns production, right? We do not own the services, but we are the gate to production. So if a service is out of error budget, can't change until the error budget is refilled, either because they spend some time without problems or the quarter roll over or whatever is the thing, right? So we would be doing projects in that service. It's not that we are there like the police and you can't touch it, right? But basically that's the philosophy behind this, right? So just last slide, just to finish. SLAs allows you to understand your service. Spend time defining the SLAs because once you have it, your organization, your team is going to optimize for the SLI. So if you have a well-crafted SLI, you will drive your service and your team where you want, right? If you have an ill-defined SLI, then you will have a team that is going like, well, yeah, let's optimize for speed. And then you have a service that is really fast, but really broken, for example, right? SLOs, remember that 1 more 9 is 10x the cost and 1/10 of the error budget, right? So it's expensive to add 9s. Going from 3 to 4 9s, it makes a lot of difference, right? And then the error budget, once you have these both, use it on your benefit. Burn it. It's there to be burned, right? It's your right to burn your error budget, to take your service down as you need, right? Because that's what it's for, to be burned. And that's all I had. Like, I don't even have a end of slide. Let me put the first one.
That's okay, Ramon, and I really love the last part that the budget is there to be burned. It's a very interesting sentence. No, super cool, super cool. I think we have some questions, Angel.
Yep. There is a question from Alberto Carrasco. Would you recommend any particular tool for monitoring? Grafana, New Relic, etc.
That's hard. So because we use like in-house development, also in-house developed tools, right? One is Borgmon that is very, very discussed, and Monarch, that there is as well tools there. If I have to recommend something that matches what I use at Google, it would be Prometheus and Grafana. That's very it's not the same thing, but the architecture and the philosophy is quite parallel to what we have, right? Said that, deploying your own stuff is expensive. Like understanding how Prometheus work, doing queries and showing the data well and so on is expensive. So if you're a small team, use something that is out of the box, like New Relic is good. And one that I really like very much is Honeycomb. That's really great as well. So unless you have effort to roll out your own thing, just go for something that is done. That would be my advice.
Yeah, there is, thanks. There is another one here in the chat from Daniel Gonzalez. Yeah, thanks for the talk, Ramon. I have one question. We are having some problems with keeping SLI, SLOs, docs per service, implementation config, Prometheus rules, dashboards, alerts synced. Do you have any tips on how to handle it? Right now, we are writing a lot of in-house tools for this.
So one thing, we had the same problem, right? So we at the beginning, we say like, well, SLOs is easy, right? But then since we have like 70 microservices, like, what? Like, are you telling me that we have 300 SLOs? That's impossible. And then you go looking and you have them, right? And it's like, that can be. And then we have a shit show of like documentation, configuration, like who did what, right? So what we do is have SLOs as data. So we have protocol buffers files, and you said like, so this RPC endpoint has this availability and these latency targets, right? And then we have tools that with that generate the configs for the Prometheus thingy, right? And the nice thing is like whenever you send a commit to that, for example, we have a pre-submit that tell us like, well, you need to get approval of foo, or you need to update some documentation, or this change is not great because you are going from 3 to 5.9, so it's like smelly, right? And that's nice because then whenever you want to do transformation of that data, or you want to use it to evaluate or something like that, it's nice because it's all in a single source of truth. Open source tools or so, I really don't know. I'm sorry.
Yeah, thank you. There is another one last question, perhaps, from Luis Fernandez. How many people do a team needs for each 9?
That depends on the service too, because it's I think it's you will need a baseline to build the thing, and then the more reliable you want it, the more people you're gonna need. One example is our service for authentication. We had it was a global thing and so on, and we wanted to go from 4 to 6 nights or something like that, or 5 to 6, and it was a whole rewrite. Right, so and regional and differentiated by and so it was a huge task in there, and I don't know how many people were involved, but there was a huge project, right? It's not the same to go from 2 to 3 than to 5. It's just growing in complexity. I don't know. I can't tell you how many. Depends on what you are already there. But it's a good question, huh?
Thank you very much. I don't see any more questions, so I guess we are pretty much done on that front.
Perfect then. Thank you very much, Ramón. I think it was a very, very cool talk. I can tell you that I will try to reach you later or on the chat for more questions, because I have a couple. But for the sake of the time, I will let the stage now to Leonardo Murillo, which I can tell you he has a really good talk as well.
Cool. Thanks, everybody. Am I audible? Yes, I think I am. Cool. All right. So, well, first of all, thanks to Marcos and Angel for having invited me to talk about observability, right? And I don't know if you did it by design or by accident, with the fact that we had an SRE talk right before. I think it's pretty matching. So today we're going to be talking about observability in the world of the ephemeral and distributed. Very quickly about me, my name is Leonardo Murillo. I'm based off Costa Rica. I'm founder of Cloud Native Architects and the Ops Institute Ambassador, and you can find my contact details on the screen right now. So please do reach out. I love to, very passionate about this subject, so love to share ideas and bounce ideas with other people. So please look me up on LinkedIn or Twitter so we can keep this conversation happening. So since we're kind of got a tight schedule here, let's start talking about what observability is and what it isn't. The first thing that I think is very valuable to point out is that observability is not just an operational concern, because I think when a lot of people think about observable systems, they naturally move into the whole idea of monitoring or alerting, but that's really not what observability is all about. Observability is really a property of how a system is built. It's considered from the point of design, and the whole idea is that the various components of a distributed system, as they're built, they've built in a way that they can provide enough data so that you can understand their behavior and you can understand their health. And by using that information, you can define a baseline of what the expected behavior is. You can identify how your system should usually operate. Now, I think it's very important to also highlight that nowadays, I think the whole idea of distributed system goes beyond computation. And what I mean by that is, when we think about distributed systems, we're also thinking about a distributed system of people. We are looking at different microservices built in different stacks by different teams within an organization that are spread around the world. And I think an observable system is one that is built in a way that allows for all those different distributed human systems to understand the behavior of a system as they're observing it, which goes hand in hand with the whole idea of kind of around DevOps of shared ownership and shared ownership into production, for example. Your system is observable when you're providing enough data, when it's built to provide enough data so that it makes sense in the context of the different services that are engaging with it and throughout the teams and people that are working with that specific service. So it's not an operational concern only. It's really how you build a solution, how you build a system that makes it observable or not. And the point is that distributed systems are going to fail in unpredictable ways. And that's very important to highlight, because when you design a system with observability in mind, you are accepting and embracing the fact that failure is an inevitable condition. We expect our systems to have bugs. We expect them to crash and to enter unknown, indeterminate states of failure. And that awareness and true acceptance, I think it's what really drives teams towards making decisions that will enhance the observability of their system. Now, if you think about what would happen when you have, like Ramón was talking about, they have 60, 70 services, and each one of those services are going to fail at some point in time because of different conditions. And they're going to be loosely coupled, but after all, interdependent and working with any number of other systems. So what happens when you put together a bunch of systems that can enter a myriad of failure states working together? Well, the point is that the sheer number of probable states that you're going to run into is going to grow exponentially as you incorporate more services into your architecture, right? So for all practical purposes, your full solution is implicitly unpredictable. Now, so what do you do about that? Because you're not really going away from failure, you're not rejecting failure, you're actually embracing failure. So you want your system to be built in a way that it's debuggable, right? The whole idea is that you can debug your system. And you debug by understanding. As soon as you embrace failure, then observability becomes really a practical concern. It's going to make your lives easier. And having an observable system is the foundation towards you debugging your application, and to be able to, a certain degree, measure how effective you have been in instrumenting and adding telemetry data to your solution. As Ramón pointed out, for instance, in the context of SLIs and SLOs, you need instrumentation. You need to send telemetry out that can be used for indicators of how your system is performing. So those very same outputs in terms of metrics or logs or traces that you're introducing in your code to handle that type of higher concern is also going to be used by the developers very personally as they debug the solution. I think it's also important to highlight that when you want coders to code for failure and you want operators to understand these different failure states and failure conditions, there has to be enough information throughout different components of a system so that everybody that is participating in the support and operation of the solution will understand the operational characteristics of the service and its dependencies. And what I'm getting at is there's going to be a number of services, software applications, as Ramón pointed out, binaries running somewhere in a container in a VM that somebody in the organization, in some team, built. But there's also going to be platform operators that are running your clusters, and there's going to be managed cloud services that are also spitting out telemetry data. To have an observable solution, you will want to make sure that there is visibility throughout that wide ecosystem, so that everybody that works with the solution will be able to understand its operational characteristics. And it's going to become very, very personal when you can leverage that to debug. I really like this little bullets that you're seeing on the screen right now. They're from a small ebook called Distributed System Observability that was published by O'Reilly. And I like the idea of how you start with a high level metric, and it doesn't have to be metric. You start with a high level something, but then you have to start drilling down, introspecting finer grade and contextual observations. And I want to highlight the idea of context because we're going to look at that soon, and then make deductions and validate those deductions. Test whether what you think is happening is actually what's happening, which brings me to the next concept. An observable system can be tested. you cannot really test a system that doesn't properly output the telemetry data that will drive the observability of the system. You need to validate that the telemetry that you're publishing, that which you're pushing out, is worthy. It makes sense, because you need to validate through testing that you can understand the complex failures that your system may encounter. And you will find out whether your system is truly observable or not when things fail. And the whole idea is you want to learn that, you want to understand whether your system really was built so that it can be observed through testing and not in production incidents. And it's also important to understand that that testing also has to evolve to really take advantage of the observability built into the system. Because a lot of times when we think about testing, we kind of just focus on unit testing or kind of like integration testing. But we really want to evolve our testing practices so that we are really taking a holistic and integrated view to how we validate the operation of our full solution. It's not that unit testing or kind of like service-specific testing are not valuable. Of course they are. But we want to test the solution as a holistic platform, as an integrated platform, and throughout the different stages of the life cycle, right? From development to deployment to release and post-release, right? And I also found this great quote that the whole idea of the problem with testing is that testing is there to effectively show the presence of bugs, but never their absence, right? So it's very important for us to maintain a continuous process of testing and increasing our coverage of holistic integral tests as we increase the verbosity and the richness of the observable telemetry that we are pushing out. Now, I'm pretty sure you've all heard about the 3 pillars of observability. Logs have been around forever. Metrics as well. They're showing some increase in adoption, I guess, in recent years. And traces are becoming ever more relevant when thinking about distributed solutions. Now, we mentioned a keyword a few minutes back of context. If you ask me to truly observe a system, as much as these data sources are valuable, alone they will not help us reach these necessary objectives, because context is king. We must incorporate context into our telemetry data by enriching and extending every particular data point so that we have a broader view of a distributed request. What milestone has the user reached? Where in the life cycle of this request was this piece of information produced? We need to enrich our data with context for the system to be truly observable. We're not looking anymore at system-specific or system-individual metrics or pieces of information. We're looking at how those pieces of information interact, where they're present in a more global, in a global view of a holistic system. Now, talking about some key concerns as to how we instrument ephemeral systems. To clarify, an ephemeral system is one where things may go away. Think, for instance, functions as a service. They're invoked, they might run for milliseconds and disappear. Think about auto-scaling solutions where containers or instances are going up and down and they're constantly changing. They're in a constant state of elasticity and entropy. When you think about ephemeral systems, you really cannot consider the idea of scraping or pooling data. So like if you think about your Prometheus, for example, or any other tool that is the time series database storing your metrics, you cannot expect to scrape this data from your services because they are going to be spinning up and down. They're going to be running for milliseconds at a time. So a lot of times for ephemeral services, you're going to have to push that data out. But you're going to have to push it out like really fast. Because if you think about, for instance, a function as a service that's running for milliseconds, it cannot take a second in addition to its runtime for you to push that data out. It has to be super fast. It has to be non-blocking. And that means a lot of times it has to be brokered because your service, your ephemeral service that is being invoked, cannot wait for acknowledgement that the data has been received, but you cannot lose the data either. So usually you'll need some sort of queue or broker in between that is going to handle guaranteeing that this data is going to end up in its final repository. And one other key awareness that you have to have when designing your system and when understanding how to extend and enrich your telemetry with enough metadata so that you understand context is that by the time that you go to identify causes for failure states, the system that originated that request may have long been gone. The one instance that triggered that error state, the one function that was invoked, may not be running and may have not been running for some time already. So you need to make sure that your full solution is instrumented so that it becomes observable, so you don't lose components that you're going to need eventually to really make sense of what happened during a failure state. And of course, for you to be able to make a holistic sense, to have a holistic view of your solution, your data has to be integrated. You need to think solution global, not system specific. And to be able to integrate data doesn't just mean you're going to push all your data into one single place, because that's kind of like prerequisite. Ideally, you will want to have the data queryable together. That doesn't necessarily mean that it has to be in one single place, but it means that you're going to want to be able to query data from multiple services and multiple sources and different types of data, logs, metrics, traces, etc. You want to query them together and make sense of them together. But that's not the only component of integration. There's also a very relevant sense of common semantics. And what I mean with common semantics is, let's imagine you have a system where you have, I don't know, users or products, right? If 10 of your teams refer to a user as a user, but one team refers to a user as a person, it's the same entity, but there's a different semantics referring to that entity. Your life is going to be way more complicated making sense of a distributed observable system. So you want to make sure that you define common semantics and you share those semantics across your team. And the same goes with metadata. You want to make sure that you have enough key values stored as in a schema that is consistent across your different teams, so that you will be able to get consistent context regardless of where this data is coming from. So this is kind of like a contract that has to be established from or within all the different teams. And of course, in terms of integration, you want to think in terms of processes and milestones, not individual requests. Like you no longer care kind of like about just the latency of one query. You want to understand how that one query impacts a full process and how that one query may or may not allow a user or a process to reach a given milestone. So these are very relevant components to consider when you are thinking about how to integrate data from multiple services that are observable into an integrated solution. And of course, as we started this conversation, right, a lot of people think about monitoring and alerting when thinking about observability. To me, of course, observability is not a synonym. It's not synonymous to alerting and monitoring, but they're very much interrelated, because you cannot effectively monitor or alert on a system that is not observable. And what I mean by that is your insights, what knowledge you acquire by testing your system and leveraging your observable data to understand complex failure states. That is going to be the source of knowledge that you will actually use to define what to monitor and to define where to alert. Alerting and monitoring is the next logical step to how we take advantage of an observable system. Because as you're debugging, as you are testing, and as you're validating that your solution works, as you are looking to increasingly predict, then you can monitor those things that you now got to a point where you can predict, because that's the fundamental difference. Monitoring is about what you can predict. Observability is understanding that what you can. So they're not the same, but they're very tightly related. So let's imagine you have an observable system, right? You've worked with your teams and you have common semantics, and you are storing data in an integrated way, and your system is observable, and you're continuously testing it and validating it. So next. Well, these are just a few things. So new release patterns. For instance, if you think about progressive delivery, or more specifically, canary deployment, which is where you deploy you release a new version, and you only direct a percentage of your production traffic to that new version, which effectively is testing a new version in production. Your observable system will be the foundation to automatically assess the health of that new version. And that is going to feed back to your progressive delivery tool of choice as to whether it can be directed more traffic or not. Just as an example of how an observable system enables new release patterns. I also think that it enables the adoption of DevOps because of multiple reasons. And there's multiple principles to DevOps that I think are important. One is continuous improvement and fast feedback cycles. You cannot continuously improve something that you cannot measure, right? Understanding your current state is a prerequisite to defining a next ideal target state. So if you don't understand your current state, you'll never know whether you're progressing or not. You're just moving, but you don't know whether you're moving in the right direction. So observability allows you to understand that initial state, the current state, and define a desired target state. It also enables continuous feedback and accelerates feedback cycles, because now you're not going to have to wait to run into these indeterminate failure states in production to be able to understand more. Your system and your testing and your validation and the information that your system is producing is going to allow you to accelerate those feedback cycles. And of course, when you have this platform of shared knowledge, right, where all these components of your distributed solution are producing observable information, and everybody across teams can see that, then you're supporting this whole idea of shared ownership and collaboration. We heard a lot about SRE. A critical component to SRE is understanding the behavior of a system, right? When you want to understand what objectives you want to hit, when you need indicators to be able to back those objectives, you need an observable system. And of course, if you think about newer practices such as chaos engineering, you need an observable system to understand the blast radius of your experiments, to be able to hypothesize and validate once you introduce chaos into your platform, into your system. These are just a few of the different opportunities that arise when you design and build your system with observability in mind. So that's what I wanted to show you. Gracias a todos y todas. And thanks to the Cloud Native Asturias opportunity. And I don't know if there's any questions. I'd love to answer them.
Thank you very much, Leonardo. I think it was a great talk. Actually, I remember myself when you told me the title, I was very excited because observability in my personal experience is really, really key. I mean, in these days, distributed system, if you don't have a strong observability and you really care about observability, you will fail for sure. So
yes, I think that's very valid. I mean, you have systems, and it will make the lives of everybody easier, right? I think it's an observable system is good for happiness as well.
I can tell you. Angel, I don't know if we have questions over there.
I don't see any questions. I don't know. I do have one question from
I do have as well.
I do have a question which is pretty straightforward. What would you suggest or recommend, or kind of resources for someone that, for a company that it hasn't invested enough or it hasn't invested yet in observability? What would be the entry point? What would be the starting point to look up at this like really important subject, but perhaps is not known for to everybody?
I think where I would start is first I'd like to understand kind of like this hypothetical company, where are they on their instrumenting of their solutions in the first place, right? Because I think observability is moving from instrumentation to knowledge. So if you're not really instrumenting, you still have homework to do, right?
Mm-hmm.
So work with the teams to understand how to instrument. Education is super important. How to instrument, what are the proper mechanisms to instrument, what standards do we want to apply in an organization as to what logging libraries we're going to be using, what are we going to do JSON logging or not, kind of like start at that level. And education, there's great literature, as I mentioned, that small ebook, what's the name, Observability of Distributed Systems is a great starting point. There's a lot of literature, so I would encourage either establishing some formal education process, or working with the SRE teams, or working with the Cloud Center of Excellence, or looking for some organization within the enterprise, depending on the size of the enterprise, that can promote the adoption of these practices. And then I would also suggest, if you are just getting started, do not try to boil the ocean, right? Do not try to apply observability across the board. Understand maybe which are your simpler systems, right? Which are your simpler services, and start from simple and raise the bar as you become more comfortable with the concept. Does that make sense?
Yeah, it makes a lot of sense, and yeah, thanks for the tips.
I have a question for Leonardo.
Okay.
Actually, maybe two or more. You mentioned tracing. For me, tracing, I must to confess, that is my the part that I miss the most. I don't have much more over there. But I see tracing. I see, for example, you can instrument your application, your microservice or whatever, and you put tracing, and you can see, okay, this request is coming through all these other microservices. You can trace everything. But I see, should we also try to, let's say, join that tracing that we see in terms of requests and metrics with the logs as well? So try to tend a bridge between both in order to have a very good observability system?
Let me answer that question in two directions. As I mentioned, I think you need to have common semantics and common metadata, a common schema to metadata. That to me is the way that you can bind these different data sources together. Okay, so by injecting a kind of like unique request ID that is present both in your traces as well as in your logs, you can relate different types of data, even metrics, right? You can, if you insert unique identifiers, if you insert unique context data, whatever that is, whether the user, whether the unique request, whether the database session, like whatever you need to use to provide traceability across different types of data, I think will get you that objective, right? You can see a trace, you can see the different spans within that trace, and if you want to understand what was happening in a given system over the lifespan of a span, you can go and search for the logs for that time window, and you can look up for that one identifier that was in the trace and correlate it with your logs data. So that gives you that opportunity to relate different types of data. Now, I do not think it is a good idea to expect traces to do what logging is expected to do, because logging is a lot more unstructured sometimes. I mean, you have strings and kind of like free form data that you're using to provide very granular insights into some event occurring within a system. I think you need to solve different problems to handle logs at scale. Logs at scale are basically a stream processing problem. How do you process this continuous stream of dense data that is semi-structured, because it might apply to a schema, but the messages themselves necessarily may not be, right? The repositories where you're going to hold that data also require different characteristics. When you are thinking about logs, think about, for instance, Elasticsearch, right? You have a search engine that allows you to do very complex querying on free text, because you might want to search for specific keywords in the output of your logs. That system is not the same that you're going to need to store spans and traces. Spans and traces are stored in a system that allows hierarchical relationing between entities, right? This happened because of this parent, and this parent happened because of this other parent. The data structures that it implements are optimized for those scenarios. So we're actually talking about two different types of data that each one needs a different system. Handling them at scale represents different problems, but you will want to be able to relate. So you relate through a consistent metadata, a schema of metadata.
Thank you very much, Leonardo. I understand what you mean. I think makes a lot of sense, by the way.
Cool.
I don't know if we have any other questions for the audience. Otherwise, maybe we can do the wrap up. So I will share my screen. By the way, before to share my screen, Leonardo, correct me if I'm wrong, but you will be attending to the KubeCon next month?
Yes, I'll definitely be there.
So please, I can recommend you the KubeCon, and please follow Leonardo Murillo in the KubeCon. He's willing to do it, and keep an eye on it, because he has a lot of things to say. So I will now share my screen. So just to wrap up, again, thank you very much, Leonardo. Ramón is already there, is already out, because, family, we have to conciliate everything. So thank you as well to Ramón. Thank you to all the attendees for your questions, for your participation. I hope this is useful for you. You learn something. And yeah, last but not least, as usual, as not usual, at least we did it last time. We will do now a post-event talk in Twitch. There we will be Angela and myself. Now you can see we are sharing some links over there. So again, thank you very much, and have a nice day. See you soon. Ciao.
Thank you all. Bye.
Thank you, everybody.